Okay, so this time we're going to take a look at page 478, number 17, and it reads, a geometric series has three terms. The sum of the three terms, so the three terms have a sum of 42, and we know that the third term is 3.2 times the sum of the other two. And the question is, what are the terms? So we're going to take a, uh, I worked this one out already, and I have a way of doing it. So hopefully this way isn't too confusing or too roundabout. I'm sure there's 10 different ways of getting through this problem, but I'm going to start here with an interesting little substitution. So over here, I'm going to say t1 plus t2 equals 42 minus t3. So I'm going to take that substitution because t1 plus t2 is equal to this. That is going to go in here because that's t1 plus t2. So what I'll end up having is t3 equals 3.2 times 42 minus t3. And that's going to give me one equation with only t3 in it, which is nice. So t3 is going to equal 134.4 minus 32 3.2 t3. I'm just going to double check my math on that before I do anything else. So I'm going to just 3.2 times 42, 134.4. Okay, good. So now I've got over here, I'll add that t3 to both sides, and I'll have over here 4.2 t3 equals 134.4, and then I'll divide both sides by 4.2, and I'll end up with 32. So T3 is 32. Now that's actually part of the answer because we're looking for what are the three terms, but this is going to be an important piece of information here. T3 is equal to 32. And because it's a geometric series, I know that's equal to AR squared because that's what T3 is equal to. Okay, so if I know that that's 32, then I can sub that in up here, and then we'll have 32 equals 3.2 times t1 plus t2. So then divide both sides by 3.2, and I get 10 equals t1 plus t2. Now, consequently, if I sub that 32 in right here as well, just to verify, if I subbed in 32 right here and then subtracted 32 from both sides, I still would have equaled t1 plus t2 equals 10. So I've got that. Now, what we know is that t1 is also known as a, and t2 is also known as ar. So I know that 10 equals a plus ar. So if I factor a, then I get 10 equals a times 1 plus r. And that means that a equals 10 over 1 plus r. So that's just a nice little formula here. That's the relationship between a and r. And that's something else that I'm going to be able to use later on. Now, I'm also going to look at this formula up here in terms of all of these variables. So I've got a, ar squared. I'm going to sub all of those in right here, and they're going to be equal to 42. So that's going to mean that a plus ar squared equals 42, or a times 1 plus r squared equals 42. So now I'm going to make use of this formula right here. I'm going to sub that in to that a. That means I'll have an equation with only r's in it. So that means I'm going to have here 10 over 1 plus r times 1 plus r squared equals 42. I'm going to multiply by the reciprocal to get this quadratic all by itself and to bring this r up into the numerator. So I'll have 1 plus r squared equals 4.2 times 1 plus r. Expand, and I'll get 4.2 plus 4.2r. Bring everything over to one side, and I'll have r squared, because I like to put the r squared first when I'm about to do some factoring, minus 3.2r minus 3.2 equals 0. Now, I don't like factoring with decimals in it. So what I'm going to do is, I'm just going to move this up a little bit. Okay. So I'm going to multiply through to clear that fraction, or to clear those decimals. So I'll have 10r squared minus 32r minus 32 equals 0. I'll notice here that I can divide through by 2. So I'll get 5r squared minus 16r minus 16 equals 0. So this, I'm going to see, because this looks like it will probably factor. So I'll just set up over here, my product between my first term and last term is negative 80. My sum is negative 16. So two numbers that multiply together to give me negative 80, that add together to give me 16, that's going to be negative 20 and positive 4. So if I follow through my tricky little factoring method, then 4 there over 1. So I'll have that will factor to r minus 4 times 5r plus 4 equals 0. So that means r is equal to 4 or negative 4 over 5. Okay, so that's r. So I can see that I'm going to have two answers for this. So I don't think I'm going to have quite enough room here. So I'll bring in another page. So what I'm going to do here is I have a relationship up here between a and r. So I'm going to sub my values of r equals 4 or negative 4 over 5 in there to get my two different values of a. And that is going to give me 4, r equals 4, a is going to equal 10 over 5 or 2. For r equals negative 4 over 5, a equals 10 over 1 minus 4 over 5. Well, that's going to equal 10 over 1 over 5. That's going to equal 50. So my first term is either 2 or 50. My next term, that'll be a times r. So that'll be 8. Over here, a times r, if I multiply that here, then I'll get negative 40. And ar squared, well, I already know that from earlier. Ar squared is equal to 32, but I can verify that. 4 times 8 is, in fact, 32, so that works out. And then over here, ar squared should equal 32. And let's just double check. If I multiply through by negative 4 over 5 to get my next term, that'll divide and give me negative 8. Negative 8 times negative 4 is, in fact, 32. So my three terms are either 2, 8, and 32 for T1, T2, T3, or 50, negative 40, positive 32, T1, T2, T3. So those are the two possible solutions to this problem. And we hopefully had a good time doing that. So thank you very much. Take care.